Have you ever wondered what this little integration symbol could actually mean? Yeah, me neither. Anyways, let's find out. Let's take the most basic function possible, y is equal to x. This function is so easy to understand that even your one friend who hates math more than anything else should be able to understand it. This function basically means that for every y value, the x value is the same. You also might know the function y is equal to x squared, which says that for every y value, the x value needs to be squared. For instance, if you have x is equal to 2, then y would be 4, because 2 squared is equal to 4. Wow, this fits easy, right? The cool thing is that with what I just taught you, you could basically now know how most functions would look like on a coordinate system by just looking at the formula without needing a calculator. For instance, when I was in 10th grade back in the days, I would just memorize how the formulas look like. For example, the function x to the power of 3 looks like a giraffe with only 2 legs. But now you can just plug your x coordinate into a function, evaluate it, and get the y value. Anyways, let's say we have a more complicated function. Let's say we have a function y is equal to x to the power of 3 plus x squared plus 6.9. If we plug for x equals 1, then we get our first y value of 8.9. If we now plug in our next value, which is 2 because I'm not in the mood of being creative, then we get our next point. And with that we could draw our function. You could also plug in the negative x values if you want to feel extra. Anyways, let's get back to our favorite function, y is equal to x. In order to get this area from 0 to 5, we can use the formula of a triangle called 1/2 times base times height. In this case we have a height of 5, and because of that our area is going to be 12.5. Now you might say, yeah, no shit Sherlock, but the functions I get in my math exam look like this or that, if your math teacher truly hates you. Okay, you got me. Let's say we want to get the area of our good old friend x squared from 0 to 5. In order to get this area, we simply use the formula of the area of a banana. But if you don't want to use the formula for a triangle nor a banana, then you can also use the formula for the area of a rectangle. But I would suggest you to use the formula of a banana. Well, let's say you chose the area of a rectangle, which is width times height. Well, if we put the rectangle under the graph, then we notice that we don't get the whole area. I'm pretty sure that people often say to you that size doesn't matter, but in this case it does. So how do we get the whole area? Well, if you notice the following, then you see that the more rectangles I add, the lesser the overall missing area is left. So our estimate of that area becomes better and better. Do you still remember the part where I told you about how to get the area of a rectangle? We used width times height in order to get the area. And when we use integrals, we call the length of each of these tiny infinitely small rectangles dx. And the height would simply be the height of a function over the given dx. So in this case, it would simply be x squared. So basically we are just calculating width times height of each rectangle. And because we are doing this an infinite amount of time, between x is equal to 0 and x is equal to 5, we simply use the integral sign from 0 till 5, which basically represents the sum of all these rectangle areas.